Yeah, just ignore. We've got so many other things going on. My son had his sleep deprivation EEG last night, so like we didn't sleep at all last night. So to get him to his so we're kind of a little frazzled today.
Okay. Let me open up the Hangout. Yeah, it doesn't look like there are any meetings next week.
Well, at least we'll just have one more and we can be good. I wasn't a fan of the, I don't know, I guess just like the format of the online class. My husband's also in this class, but he's with a different teacher and they do exactly the same thing. And it's just, I don't know, I guess I prefer the classroom where the teachers can kind of do it a little differently versus, I don't really like the formatting of online math.
Yeah, I know what you mean.
But plus I'm not really here's this resource stuff, go figure it out yourself. With math I like it to be explained, but
yeah.
Where's my group thing?
Okay. It says, ensure each team member understands how to solve a system of equations using the Gaussian method elimination. And that's basically setting the matrix to where it's 1, 0, 0, 1, and then whatever we get left over is the answer.
Yeah, is there any simpler way? Because I know, like, you can have R1, let's say times 2, and then it will equal it, or, R1 plus R2. Is there any simpler way of, like, figuring out what it will most likely be? Or do you just have to look at it and guess, well, maybe if I have 2 and added it to 1, it would equal this? Is it just a look and guess kind of thing?
That's kind of what I'm thinking, yeah.
Yeah, I was looking up and trying to see if it actually had, like, here's the system, A equals this, B equals this, solve. But I mean, it's not hard. I guess it's just tedious trying to see, well, that one equals 0, but this one doesn't. And
yeah, and it's trying to remember like what you are able to do and like timesing this by whatever and then adding it to that, or like this to that, or whatever.
I do understand it well, though. I feel like I get it. Yeah, it's just
making sure you don't mess.
Right.
Ow. Oh. Okay.
So then it's discuss the results from the invent matrix multiplication worksheet. I mean, I felt like that was, I ended up getting, for the end of the results, I guess for number 6, Monday I got 3,000 pounds, Tuesday 31,000, and then square footage for Monday I got 1,600 and Tuesday 1,700.
I'm trying to find my thing. Where? Oh, here it is. Yeah, for Monday I got 30,000 pounds, 1,600 feet squared cubed. Is that what you got? That first one for Monday?
Here, give me a second. Which ones did you use? There's ones on the floor.
This one's on the bottom shelf.
No, there's on the floor in front of the shelves in a bag. Sorry. Monday, 30,000 pounds.
And then 1,600 feet cubed.
Yeah.
Okay.
And 31,000 and 1,700.
Yeah, for Tuesday.
Oh. Okay. Yeah. And I mean, I felt like that was pretty much like I wrote them out long to be where it was like, 40 times 500 plus 50 times 200. So I guess I can see how you draw from the table to make like the 2x plus 3y equals blank equation. So made sense. I kept looking at it and I was like, this has got to be more complicated than just multiplying
Yeah.
or something. Let me see. It's given two matrices. How do you know if you can add or subtract? If it is possible, how do you perform the addition subtraction operations? For the addition subtraction, are those the ones that have to be the same size, or does it just have to be okay?
Yeah, they have to be the exact same dimensions in order to add or subtract them.
Okay, and then you just use each value. Like if it's a 3 by 3, it's this one goes with this one, that one goes with that one, and
yeah.
Okay.
Exactly.
What's the next one? I don't even know where we were. Given a matrix, how do you know if you can do scalar multiplication? If it is possible, how do you perform scalar multiplication? Is that where you have the number, like the preface to the matrix, where it's like 3 and then a matrix?
Oh, I think so. Yeah. Yeah.
And then you just do it for all the values in the matrix, right? If it's a half, if it's a whatever.
Yeah. It like distributes into everything, I think.
Yeah. Yeah. See, a lot of this, I feel like I just got to make sure. I'm like, it's just as simple as that, right?
Yeah. There's like no trick to it.
Right.
Okay. And then given two matrices, how do you know if you can multiply?
I know the multiplication one, that's where you have to have, the first one's got to have the rows, and then the rows have to be the same as the columns of the next one.
Okay.
So if you have one that's like 1, 2, and 3, but then your next one is 1, 2, 3, 4, like just 4 tall, you can't do those because you have a 4 and a 3 and it doesn't.
But if you had a 1, 2, 3 and then a 1, 2, 3, you could multiply them?
Yes, those work.
Okay, that makes more sense to me now.
So and those like yeah, let's say you have like a 3 and a 3 like this, and then so you do this one and this one making a value, this one and this one, and then they make new values for.
Okay.
And then for matrix solutions, just to because I think I was having this issue in the assignments, that it doesn't want the answer in like necessarily like points. It wants them in the little matrix brackets. Like, so do all matrix like problems end in a matrix bracket as well?
I know if you're adding or subtracting, it does, but then I think if there are like some cases where, oh, wait a minute. Okay, yeah, I see what you're saying. I think if you're doing things with matrices together, like adding, subtracting, or multiplying or whatever, then it is within the brackets. But like for the Gaussian elimination method, I think that's essentially a system of equations.
Okay, so that solution would be like a point or something.
Yeah, so you're taking what you have, like the two equations, putting them into a matrix form, solving it, and then putting it back into a point.
Okay. I see. Oh, okay, true. I see what you're saying. Because then whatever answer you'd get, I mean, that's what your X and Y values are.
Yeah.
Okay, that makes sense. That's something I kept getting answers wrong on the assignments, and I wasn't understanding what it was asking. And then my answer was right, but I didn't put it in the format. I was doing it in like the point form and not the matrix bracket. So
Yeah, I did that a couple times too.
right. Well, I hate it. I hate it when you work so hard on a problem and then, it's like, you do it and it's not right. And you think maybe I put a space or something and you keep checking it. And then you're like, oh, well, I guess I'll do another problem, even though I did all that work and it counted it wrong.
Mm-hmm.
But, oh, well. Okay. So I guess we can do the extension problems. They're not too bad. I mean, it's just solving these and then doing the other ones for the matrix.
Okay. We can start on A, I guess.
And do you know how to because you can solve it through this method, and if you ever want to check yourself, you can plug it into the calculator and make sure that your answers are the same one. I figured out how to do it via the calculator.
So like matrix via calculator?
No, I can't pronounce it. The Gaussian elimination. The calculator will do that.
Really?
Yeah, and it will do like the 1 0 0 1. It'll show you exactly how to do this. I can show you how, but it's a really good method to double check yourself.
Okay.
Just to make sure that the way we work it out by hand is also the way it's solved on the calculator.
Okay.
So super nice to have that.
This is the calculator I have. I'm not sure, like, know how to do it on this.
Do you have a matrix button? Or do you have like a catalog button?
I'm pretty sure I have a catalog button.
Because it might.
Like a CA?
Yeah, it might be under, like sometimes calculators, like all the functions they do will be just in like a big folder of like everything they're possible of doing. So sometimes you might be able to find it there.
Okay.
But I know I have a TI-84, but the command is RREF for it's like row reducing equation formula is what it calls it. But yeah, it's RREF, and you can plug in the matrix like that.
Okay.
But yeah, I'm not sure on some other calculators.
Yeah, I might need to get a new calculator for calculus, but I'll cross that bridge when I come to it.
Oh, there's always people like getting rid of them and everything too. So.
Okay, good to know.
First, we have to get it to be 1001 is what we're going for. So whenever you do it, like the first, like one of them, you try to make it 1001, you have to get a number that will turn them both into that, like at the same time, right? Well, I guess it'd be pointless to solve for 1 and not the 0 in the same row, because then you still have to multiply. Never mind. I was thinking something different. Oops. Let me get the charger for my computer. And see, I feel like a lot of this is just like a guessing game.
Yeah, pretty much.
you want food, you need.
Oh. Yeah, because it's. Mm. Mm-mm.
I don't know about you, but I'm getting stuck with funky fractions. But looking at the answer sheet, the answers are fractions. But I don't know. I think I'm just starting to calculate them wrong. And
I'm on the last step. I have y correct, but I'm having a little bit of trouble finding x.
oh, okay.
My God. Aha, I got it.
Oh, you did?
Yep.
Yeah, I think I'm going the right path. Yeah, I ended up over something over 12ths. I'm sitting here looking at it like, what in the world? That looks terrible. But no, the answer is a fractions anyway. So I wasn't off. I see. Hold on. I saw for the X, but I'm still trying to get to the Y. Yeah. Wait, X is the 25 over 11.
Yeah.
Yeah, okay. Am I still getting 5 over 12? I think I'm writing it down wrong. Okay. Now we're good. Let me see. And then the Y is -6 over 11.
Yeah.
I was getting 5/12, and I don't know how, but I get my fractions confused when I start writing, because I write them on separate lines, and sometimes I treat them like separate numbers and not fractions. So that's just me. I feel like that one was harder than the assignment ones.
Yeah, I think because it started out with a 2 in the x place instead of a 1.
Oh, true.
Because we had to, like, it forced us to use fractions, which made it confusing because we hadn't done that before.
Uh-huh. Okay. You want to work another one?
Sure. When I was looking at the answer key, it said that this next one has no solution.
Oh, how do you know that it has, like, I mean, how would you calculate? Would you just keep calculating it out forever and it wouldn't solve?
That's my question. I'm not sure.
Yeah, maybe let's try working that one out and seeing if I think I saw somewhere that it said that if they come out to you know how instead of being like the 1001 kind of thing, that I think they'll come out looking either like similar or something. Oh, yeah. It's in the textbook on page 628. So if they're yeah, it's like when you try to solve it, the ones and the zeros won't be in the right place, and there's nothing you can do once you get it down to its lowest one. So
And also kind of looking at it just like after I wrote it down, I moved the y over so that it's x plus y equals 6. And then looking at 3x plus 3y equals 4, that doesn't really
Oh, that even if you look like that, it's already they're already kind of equal and not.
Yeah, because if you, in order to make the two equations like the same or similar, you times the top one by 3. And so you get 3x plus 3y equals 18. And then this one would be 3x plus 3y equals 4, which doesn't really make sense.
Oh, I see. And yeah, you're not going to be able to do that since they're just going to end up the same either way. I wonder if that's something that it's safe to assume if you look at it beforehand.
Maybe, I'm not entirely sure, but
yeah. But yeah, I can see how that makes sense. That's interesting. Probably going to have one like that on the test. Do you know, is it a comprehensive final or is it like the section final?
I'm still kind of confused because it did say that on the final we were going to go over the last 2 parts of the homework. Because it said that the first 2 parts of the homework were going to be in exam 4B, as well as like parts of the last test, exam 4A. So maybe it's like, I don't know. I'm just rambling. I'm not sure.
Oh yeah, and then it says the series and sequences, which are only going to be on the final, not on 4B.
Yeah.
Well, yeah, but yeah, see, I guess it'll have some stuff on there, but I don't know if it's going to be part comprehensive and part what we're currently doing, kind of like finishing up the semester.
And that's probably what it's going to be. We're going to finish out those last 2 modules, and then it's going to have other stuff on it.
Oh, okay.
I don't know, but
yeah, well, I didn't expect there to be a written portion because I mean, she still has to grade it. So yeah, I imagine that's going to take a while, but anywho. Okay, well.
Is it just a written portion?
No, I think there is a multiple choice because it has a written portion that says must read to access exam. And the times in the past, that usually opens up the multiple choice. It doesn't have one listed, but I don't know. There usually is one that opens up, but I wouldn't doubt. I mean, there's no way you can grade like 30 kids' math tests and have it submitted for like, graduation and everything. But
yeah,
I don't know.
Good point. I don't know.
So.
Do we want to try a couple of these matrices before we end?
Yeah, let's pick a couple.
Okay. Well, I guess we can start with that first one. It says it's possible, and we know that A times B is possible because they're both 3 in either direction.
Yeah. So that would be... Okay. Let me see if I... So it would be 4, 6, 8, -6, -9, -12, and then 2, 3, 4. It's not too bad.
Did you set it up which one did you put first?
So I put A first, and so
Oh, obviously, because A times B, not B times A.
yeah. So I just did it in my head, but here, but I did like you have since it's 3. I did like since A is 2. What's the first value of B here? And then 2 times the next value of B, and then 2 times the third value of B, and then I did the same with -3, and then and then the 1.
And so it should be 2 times 2 plus 2 times 3 plus 2 times 4.
Yeah, well, not plus together because they just make a 3 by 3 matrix. Since you're multiplying them.
Oh. And
Yeah.
I think there is an explanation for how like the 3, since it's 3 rows and then 3 like the 3 rows of 3 columns will equal out a 3 by 3. But I know it doesn't always work by that logic. So I can't remember where I read that. I think that might have been an assignment.
Okay. Yeah, looking at the answer sheet, you're correct. I'm just trying to, because I remember on like past assignments, like adding those things together, but maybe it's like for certain, like it depends on what the matrix is going to form or whatever.
Yeah, well, see, the adding you can't the adding it would work the way that you're thinking of, but you couldn't add these since they're not the same size.
I mean, like multiplying 2 by 2 and then adding 2 times 3 and then adding 2 times 4 to get.
Yeah, actually, I think you're right. Didn't we do that in one of our?
I feel like we have, but
what was
I don't
that?
know, like the rules.
I don't know that. I think that might have to be something with like whenever you're solving for like equations, I don't remember, but yeah, I remember there being something like that.
Okay, that makes kind of sense.
But like, for example, one of the problems further down is A plus C, and those aren't the same size. So you can't add those together. But I know there was something where you multiplied and added, but yeah, I can't think of it off the top of my head. Let's see, what's another one we can. 1, 2, 3.
So we can't do B times C because they're different sizes.
Or no, wait, 1, 2, 3.
And then 1, 2, because this one has two columns, and this one only has. This one's a 1 by 3, and this one's a 3, or a 3 by 2.
Okay, hold on. Wait, here's where I'm confused now. Yeah, because see, okay, if you look at the answer key, A, B is solved like the way we just did, but B and C are only 2 points together, and they are solved. So
What?
Yeah, what is that?
B and C is 20 and 21.
Like, I just thought we couldn't do that. But
that doesn't really make sense to me.
B and C, because see, yeah, according to my definition, you shouldn't be able to do that.
And then just below it, it says for E times D, it says they're not possible because the columns of E don't equal the rows of D.
Yeah, so E has 3 columns and 2 rows. Okay, B has 3 columns. Okay, B has 3 columns and C has 3 rows. But shouldn't there be like another number there?
You would think.
Here, I have an idea. Let me plug it into my calculator real quick, and
Okay.
I'm just going to plug in both matrices and see if that's what actually comes out. Because if that's the case, then maybe it's just a typo.
Oh, okay.
3. Okay, and this one is a 3 by B and C, so it's a 3 by 2. 2, 3, 4, 5, 1, 0. Okay, and then they're multiplied together.
Yeah.
Yeah, it comes out 2021.
Huh.
I am not quite sure how, but yeah, I don't understand how that. I don't understand how A and B is what it is, but then B and C is what it is.
Yeah.
So that might be a question. I might shoot the TA something and be like, hey, I'm really not understanding how this applies.
Okay.
And
I think I'll ask the math people at the math lab tomorrow too.
okay, maybe there's a rule we missed somewhere.
Yeah.
But
Okay. Let's go ahead and do 3e minus 2f and then finish up.
okay, sounds good. 3 equals. Oh, I'm silly. 2, 2, 2, 2, 2, 2. Okay, I finished up that one.
I just finished it too. And I got what the answer key says, so I'm good with that.
Yeah, me too. At first, I didn't get the answer, and it's because I did them both by 3. I didn't do F by 2, but I redid it and I got the answer. So.
Oh, gotcha.
But
Oh.
seems pretty straightforward there.
Yeah.
Okay. Well, I'll go ahead and let me stop the broadcast and get this submitted.